A social turning point has occurred. Famed theoretical physicist Michio Kaku predicts that the next 100 years of science will determine whether or not humans survive. Will we continue to be a Type 0 society, or will we develop and reach the stars? According to experts, when a civilization expands and develops, its energy needs will quickly rise due to the population expansion and the energy demands of its numerous equipment. In light of this, the Kardashev Scale was created as a mechanism to gauge the level of technical development of a civilization based on the amount of useful energy it had available. This was originally just tied to energy available for communications, but has since been expanded. What is the Kardashev Scale? The scale was initially created by Russian astronomer Nikolai Kardashev in 1964, who was looking for signs of extraterrestrial life within cosmic signals. It has 3 base classes, Type 1, Type 2, and Type 3, each with a different level of energy disposal. The scale has been expanded by more astronomers to Type 4 and Type 5. The energy available to this kind of civilization would equal that of all energy available in not just our universe, but in all universes and in all timelines. These modifications take into account the civilization's availability to energy as well as their level of knowledge. But what does each of these categories actually stand for in literal terms? Type 1. A species is classified as Type 1 if it has managed to gather and store all of the energy that is available from a nearby star in order to meet the needs of an expanding population. This implies that in order to achieve this level, we would need to increase our current energy production by more than 100,000 times. But if we could capture all the energy of the planet, we could likewise control all the forces of nature. Even earthquakes, weather, and volcanoes were under human control. That is the general notion, at least. These kinds of accomplishments are difficult to believe, but in comparison to the potential future developments, they are merely elementary and rudimentary levels of control. They pale in comparison to the capabilities of societies with higher rankings. Type 2. A Type 2 civilization, the next level above, is able to use the entire star's power, not merely transforming starlight into energy, but controlling the star. For this, numerous strategies have been put out. The fictitious Dyson sphere is the most well-known. If you want to call it that, this apparatus would cover the whole surface of the star, capturing the majority, if not all, of its energy output and sending it to a planet for later use. Alternately, if the race has mastered fusion power, the mechanism that propels stars, they could use a truly enormous reactor to meet their needs. Gas giants in the area can be used for their hydrogen after being slowly depleted of life by an orbiting reactor. What would a species' use of this much energy entail? Well, nothing that science currently understands could destroy a Type 2 civilization. We would be able to annihilate any moon-sized object that entered our solar system and was headed toward our tiny blue planet if mankind managed to survive long enough to attain this level. Or, if we had the time, we could fully avoid it by moving our planet out of the way. But if we decided against moving Earth, are there any other options? Yes, I suppose, because we would be able to maneuver Jupiter or any other planet we choose into the path. We've moved from ruling a planet to a star, and as a result, we now own enough disposable energy to effectively protect our civilization from extinction. Type 3. Where a species eventually evolves into cosmic explorers who are knowledgeable about everything related to energy, becoming a master race. The inhabitants of this Type 3 civilization may be drastically different from the human race as we know it in terms of humans due to hundreds of thousands of years of biological and mechanical evolution. These could be cyborgs or cybernetic organisms, which include both biological and robotic beings, with the offspring of regular humans being a subspecies in the highly developed society at the time. The cybernetic counterparts of these totally biological beings would probably view them as inferior, disabled, or unevolved. By this time, we would have created robot colonies that are able to self-replicate, and as they spread out over the galaxy and colonize one star after another, their number might reach the millions. And these creatures might construct Dyson spheres to enclose each one, forming a vast network that would transport energy back to the planet of origin. But doing so would provide a number of challenges, not the least of which is that the species would be restricted by the rules of physics. Specifically, travel at light speed. They can only go so far, That is, unless they create a functioning warp drive or learn to exploit that flawless energy storage for wormhole teleportation, both of which are still in the realm of theory. By this time, we would have created robot colonies that are able to self-replicate, and as they spread out over the galaxy and colonize one star after another, their number might reach the millions. And these creatures might construct Dyson spheres to enclose each one, forming a vast network that would transport energy back to the planet of origin. But doing so would provide a number of challenges, not the least of which is that the species would be restricted by the rules of physics. Specifically, travel at light speed. They can only go so far, that is, unless they create a functioning warp drive or learn to exploit that flawless energy storage for wormhole teleportation, both of which are still in the realm of theory. Type 4. A Type 4 civilization, according to Kardashev, was too advanced and didn't surpass Type 3 on his scale. He reasoned that this would be the maximum capacity of any species. Many agree, but a select handful say there is still room for improvement. After all, there must be a limit. The energy content of the entire universe would almost certainly be accessible to Type 4 civilizations, enabling them to travel through the accelerated expansion of space. Furthermore, advanced races of these species may live inside supermassive black holes. These kinds of accomplishments are unthinkable according to earlier energy production techniques. A Type 4 society would need to access energy sources that are currently unknown to us via unusual laws of physics. Type 5. Yes, Type 5 may very well be the next step for such a civilization. In this case, beings would be powerful enough to control the universe like gods. As I previously stated, humans are still very, very far from achieving something comparable. But it doesn't mean it can't be done as long as we look out for one another and the planet. The first step in achieving this is to protect our tiny home, put an end to conflict, and encourage ongoing scientific research and discoveries. Where does our own civilization sit on this scale? Initially, according to Kardashev, mankind was a Type 1. But later reclassifications have taken a more pessimistic stance. Humanity scored a pitiful 0.7 on Carl Sagan's modified Kardashev Scale, which takes continuous values into account. On Sagan's scale, some expect that our overall power consumption will reach Type 1 levels in around 200 years. But we are still a very long way from achieving Type 2 or 3 status.